Yep.
All right.
You
What
better.
was our tree for 51? It was 17 times what? We know we already got 17 times 1 here. What was the other one? 17 times what?
It was. I deleted it.
3.
Yeah.
That's 3. You had 3. You had it. You had it. Okay, put your 17 and circle those.
How?
Put your 17 there also, next to the 3.
17.
Circle them. You had it.
Circle.
Okay, now do 17 also.
17.
Next to it. Yeah, next to it. Write 17. Right
Here?
next to the, right next
Under?
to the 3. Right next to the 3. You had it. It was just you did it on calculator, so you didn't have to do it.
Yeah.
See next to the 3 in that empty space? Right here? Write a 17 right there.
Oh, 17.
Yeah. Jesus, you made this a hard one.
Okay.
Okay, circle. Alright, so what do you see in common there?
They're prime numbers.
Yeah, which prime number do you see that are common here?
17.
Cross them out.
Another way to find the answer is that 1 and 3 are next to each other. So if you plug another one, put the two numbers are together, and that's your probability answer.
That's smart. I like it. I like it. So what's my GCF?
17.
So put it on the outside. Right, now tell everybody what you did on the inside. You have your two numbers there that you didn't cross out. What do you put on the inside?
Put 3.
3.
In that 1.
Yep. 17 times 3 is what, you guys? 51. I got that. 17 times 1 is what?
17.
Does it matter which order I put them in?
No.
Heck no. That was perfect. You did a wonderful
So you
job.
basically could switch both of them.
Yep. There. What kind of expressions are these? Equivalent, because at the end, you'll get the same answer. Excellent job. Excellent. You'll get 68 at the end. All right, let's make this harder. Everybody get their piece of paper.
Piece of paper.
Get your notes. About to make it harder, Layla.
Okay, so we're going to be talking about rewriting expressions using the distributive property. So I want to give you guys some definitions real quick. Okay, there's 3 definitions I'm going to give you. I'm going to give you equivalent expressions or equivalent expressions and distributive property. Let me just make my pencil smaller. Equivalent, make sure you're writing this down. If I write something down, you write it down. Expressions. Okay, and then distributive property. I'm going to give you 3 different definitions. Okay, so for equivalent, equivalent just means the same. I'm going to give you an example right now. 4 plus 2 is the same as 3 plus 3, which is the same as 5 plus 1. They all equal 6. They're just different ways of writing it. So equivalent means the same. Expressions. Those are problems with no equal sign. And I could give you a whole bunch of examples of that. 4 times 3, 5 plus 7, 6 minus 2, 15 divided by 5. We could go on forever with these, but these are just problems with no equal sign. So when we talk about equivalent expressions, when we create those, we're creating problems or new problems, but they're going to have the same answer. Okay. Lastly, distributive property. This is when to distribute means to give out. So go ahead and write that down because it'll help you right now. So in this case, as we talk about math, a property is just a rule. Okay, so we're going to talk about a specific property, which means distributive, or which is called distributive property. For 6th grade, you'll see something like this. Okay, distributive means you're going to give out the 2 to the 4 and the 2 to the 3. Now, something really important to keep in mind is that parentheses means multiply. Okay, write that down because that's really important. It's part of your success criteria. So in this case, we're going to multiply 2 times 4. And then we're going to multiply 2 times 3. Okay? So 2 times 4 gives us 8. I don't have any space, so I just changed the color. And 2 times 3 gives us 6. So this is equivalent to this expression. They give the same answer, just 2 different ways of writing it. Okay, so that is what you call distributive, when you have a parentheses and you give something to the other numbers inside. Make sure that you have all of this vocabulary written down because you are going to need it as we talk about our lessons. Now let's talk about the age-old question, the important question here. How do I know if I learned? I want you to write this down. How do I know if I learned? Well, that's easy. You have to be able to do all 3 success criteria. So let's look at these. I'm going to go ahead and get a highlighter. We're going to understand, we're going to find, and we're going to create. Okay, those are the 3 actions that we're going to do. So what are we going to be doing? Well, I need to understand that parentheses means multiply. All right, so that's important. Parentheses means multiply. I write it down again just so that I remember. Parentheses means multiply. That's really important. So make sure you at least highlight, if not, write it down too. Writing it just helps us remember to a new level. So first we have to know that parentheses means multiply. When you finally know that and you're like, yep, I got that, I understand it, then you're going to be putting a check mark here. Okay? The next one, we're going to find the GCF. Okay, find GCF. So you guys, we've done this a whole bunch before break. And when you see me do it right now, you're going to be like, oh, I remember this. Finding the GCF of 12 means you just do a factor tree. 4 times 3 is 12, and this is prime. And 2 times 2 is 4, and this is prime. And if you have something else like 6, 3 times 2, these are both prime. So what is my GCF? Well, what matches? A 3 and a 2. So my GCF is 3 times 2, which is 6. So my GCF is 6. Okay, so if you can find the GCF, then you've learned. Okay, last thing, we are going to create, and notice this word right here, this phrase, equivalent expressions. Highlight that, and then I'm going to use a different color using the distributive property. Okay, so you should know that at the end, you'll have some kind of parentheses. So I want you to write that down because there's 3 things you're going to have to fill in for the parentheses. Okay? So that's how you'll know if you know how to do all 3 things by the end of this lesson, then you've learned. If not, then you have to go back and figure out, okay, where am I going wrong? Where am I confusing things? Okay. So what you see here is I want you to take 2 different color highlighters. You're seeing, oops, that's not a highlighter. You're seeing this expression, and you're seeing this expression. So you have 2 different expressions. Okay. What I like to do is I like to separate them with a line so you know that there's 2 different expressions, okay? But they're equivalent. That means they're the same. So what I like to do is I know distributive means multiply, so I can multiply that because there's parentheses. I know I have to multiply 2 numbers, okay? Well, the first one, 5 times 10 gives me 50. You notice I have a 50 here. So I know for the second number, I'm going to need to get 35. So if I'm not good with multiplication, I'm going to start using my calculator. And I'm going to start typing in 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6, 5 times 7. I'm going to start typing every one of those into my calculator to see what the answer is because I have to get 35. So 5 times 1 is 5. Nope, that doesn't work. 5 times 2 is 10. That doesn't work. 5 times 3 is 15. That doesn't work. This is 20. That's not working. This is 25. No, I got to get to 35. 5 times 6 is 30. Nope, but 5 times 7 is 35. So I know my answer right here needs to be 7 because 5 times 7 is 35. So what you want to do is, now I know that they're equivalent. This side is the same as this side. And I checked it already. I said 5 times 10 gives me 50. And 5 times 7 gives me 35. So at the end of the day, you see the same exact thing. Okay, let's go ahead and go on to level 3. So this one says apply what? The distributive property to write equivalent expressions. Make sure you highlight those two different things, okay? So I know distributive property right away. It says that I'm going to have to apply it. So I go ahead and just draw my distributive property. I know I need 3 numbers. On the outside is always the GCF, okay? I know that on the inside, once I multiply, I should get 21. And once I multiply over here, I should get 42. I already know that. So let's go backwards. Let's figure out how the heck we're going to do this. So what we're going to do first is we're going to draw 2 factor trees. So I know multiplication has to do with parentheses. And so the next thing is for my success criteria, it says to do factor trees. So let's do that. I know that 7 times 3 is 21. So I'm going to circle both of those because those are prime. And for this, I know that 7 times 6 is 42. Okay, 7 times 6 is 42. I also know that 3 times 2 gives me 6. So these are all my prime numbers. Okay, let's see what's cooking here. Okay, my 7 and 7 are the same, and my 3 and 3 are the same. So for GCF, I know it's 7 times 3, which if I multiply that together gives me 21. So that's my GCF. That is going to go here. Okay, so let's put it there. Okay, 21. So I know now I have to go backwards and figure out, okay, 21 times what will give me 21? And 21 times what will give me 42. So again, if you're not good with your multiplication, you can use your calculators, or you can just start writing things down, okay? For instance, 21, I would type in my calculator 21 times 1. That gives me 21, and that's what I was looking for right there. So I'm going to put 1 here. That's my first number inside, okay? Now we have to get to 42, right? So I'm going to do 21 times 2. If I type that in my calculator, that gives me 42. Wow, I'm already done. So my inside numbers are 1 and 2. And you notice they're already checked right there. I already made sure that they equal the same thing. So this expression right here, 21 times 1 plus 2 is the same as this expression right here. They're equivalent. They're the same thing, just 2 different ways of writing them. All right, let's do the last one. Apply the distributive property. Boom, I see distributive. To write equivalent expressions. So I know I need distributive, so I right away start drawing parentheses like that. Okay. I know I want equivalent expressions, so I know when I am done, I want 6x. I want it to multiply to get 6x, and I want to multiply to get 9y. You notice I just bring the variables down. These letters are called variables, okay? So all I'm going to do is I'm going to put the x here and the y here so I don't forget them, okay? But we're going to do the same thing we did last time. We're going to make 2 factor trees. Okay, 3 times 2 is 6. Those are my prime numbers. And 3 times 3 is 9. Those are my prime numbers. Well, I'm already done with those factor trees. I can't break them down anymore. Okay, I see that I have a 3 and a 3. So my GCF is 3. Now you remember our GCF always goes on the outside. So let's draw the 3 there. Okay. All right, so I have to figure out 3 times some number will give me 6. And 3 times some number will give me 9. So in my calculator or in my head, I could say, okay, what's 3 times 1? That's 3. Okay, that doesn't work for either one. What's 3 times 2? That's 6. Ooh, that works right here. So I'm going to put a 2 here. Right? 2x. Because 3 times 2 gives me 6, and I have my x, so 6x. Okay, let's keep going. Let's try to keep going so we can figure out to get 9. 3 times 3. Well, if I put that in my calculator, that gives me 9. So I know this has to be a 3 right here. Because 3 times 3 gives me 9. So I'm done. I have 2 equivalent expressions. I have this one, which ends up being 6x plus 9 if I multiplied it out. And I have this one, which was my original expression. So they're the same thing. They equal the same thing. It's just 2 different ways of writing it. So what you're going to do is you're going to make sure you have these down, and then you're going to be working on your practice for this.